You are watching the Plant Services Fundamental video series, Fundamentals of Compressed Air. This video is brought to you by our sponsor, Kaeser Compressors. More information on our sponsor will be provided later on. You can also find company and product information provided in the information section below.
Compressed air is commonly accepted as a manufacturing facility's fourth utility. Taking a closer look at the way that fourth utility is consumed can provide maintenance savings as well as the peace of mind that comes with the assurance of clean air. However, compressed air systems typically are the most ignored of all the plant utilities in terms of energy efficiency and waste. This is true even though air compressors and their associated system equipment consume considerable electrical energy in most plants. Once a focus is put on these often troublesome systems, significant performance improvements and energy savings can be achieved by applying common efficiency measures. Industry expert Ron Marshall of Marshall Compressed Air Consulting argues for the use of key performance indicators to properly manage your compressed air system. These indicators, also known as energy performance indicators, can be compared to set benchmarks or energy baselines to determine if you are meeting your targets. In his article, Watch Your Compressed Air Numbers, Marshall outlines 4 important KPIs for compressed air systems. These 4 are a great way to start the process of measuring and monitoring and can lead to the identification of other, more site-specific KPIs to help you track your plant's unique compressed air system. KPI 1. System-specific power. System-specific power tells how efficiently the compressed air is being produced, much like a gas mileage indicator. This KPI is often measured in kilowatts per 100 CFMs, or kilowatts per cubic meter per minute. A good compressed air system will produce air at under 19 kilowatts per 100 CFM, and a bad one can be more than 90 kilowatts per 100 CFM. Improvements to this measure can be gained by upgrading compressors to more efficient styles and by applying more efficient methods of control, such as variable frequency drives or cycling refrigerated air dryers. KPI 2. Total energy consumption. It is possible to produce compressed air very efficiently, yet waste energy through leakage and inappropriate use of that air. Total energy consumption is a measure of how much total energy a compressed air system consumes over a specific measurement period. It is most often measured in kilowatt hours per month or per year. Improvements to this measure are gained by improving the system-specific power and or reducing compressed air waste. KPI 3. Specific energy consumption. This KPI is a refinement of the previous one and is expressed as the ratio of compressed air energy consumed per specific product output. This indicator can be important if a large amount of energy is expended to produce a specific product, and KPI units will vary from plant to plant and from product to product. Examples include kilowatt hours per ton or kilowatt hours per 1,000 board feet. To use an extreme example, imagine an automotive plant where the total output of the plant is 3 vehicles per day during a 12-hour shift, and the plant only operates on 5 weekdays. If the compressors were to be left running even at night and on weekends, potentially also feeding a failed dryer or experiencing leaks, then the specific energy consumption per auto unit would be insanely high. KPI 4. Leakage as a percentage of production flow. This KPI is a measure of how much system waste occurs during times of no production and is expressed as a proportion of total flow. This measurement is easy to calculate in a shift-oriented plant or during periods of planned downtime. It is more difficult to measure at locations where production never shuts down. A good number for this indicator is less than 15% of production average flow. If you discover that the air waste in your system is more than 15% of the total flow, then some leakage detection and repair work will be required. These days, the once expensive instrumentation required to do permanent measurements and KPI calculations is readily available at reasonable cost, with options to use the cloud to track and archive KPI data. Marshall adds that basic indicators like pressure, flow, dew point, and critical temperatures are also important values to track for any system, and should be monitored if they are important to system operators. Finally, the members of the Compressed Air and Gas Institute, or CAGI, also have long been involved in standards for the compressed air systems industry and have developed a reporting system to standardize the presentation of product performance data. CAGI datasheets currently have been developed for centrifugal compressors, displacement type compressors including rotary screw compressors, blowers, and refrigerant compressed air dryers, and allow a common basis for comparison of some relevant items to aid in selection of equipment.
Kaeser Sigma Air Manager 4.0. Most industrial plants use multiple compressors to power their production. If the compressors are not properly controlled, they can cycle on and off, fighting for control, leading to pressure swings and wasted energy. Using a master controller like Kaeser Sigma Air Manager 4.0 will improve your operations by increasing system efficiency and significantly reducing energy costs, tracking performance KPIs, providing full-time data logging, reducing wear and downtime, and allowing remote system monitoring, to name a few key benefits. Learn more today at us.kaeser.com/samsavingsps.